Okay, so we'll start going through on power graph. You all can take out a plain piece of paper. So the heading you can just write as power graph. Now, when it comes to power graph, there are the parent graph that you need to know. So what are parent graph? Okay, so later I'll teach you all parent graph versus the modification that is needed, the whole general idea. So in the box, right, are all the examples of parent graph. Parent graph equation. Parent graph, there is this particular drawing, right, that would be very useful for you guys. Okay, imagine this guys as a face, a head, he got a bruise here. This is his bruise, This is his eyes, his face, his body, and his wavy hands. Okay, so I'm going to teach you guys what are each of the representations of it. So the first color that I'm going to go through is the one in red. The one that look like a hat or a Chinese letter called Pa, right? 8. And Pa is an even number, 8. So just remember, whenever you see like this hat, is this parent graph called y is equal to x to the power of -2. So x to the power of -2, you already learned in indices. In indices, there's another way to write, which is y is equal to 1 over x squared. They are the same thing, okay? So this is the one in red. Now, the next one is the one in orange, which is this bruise here. The bruise that he had on his head. This bruise is actually y is equal to x to the power of -1. And x to the power of -1 is the same as y is equal to 1 over x. So just remember all this as the parent graph. Next, the next one is this. This is the eye, the left eye, and this left eye is called, this left eye, this equation is y is equal to x to the power of 0. Now, why x to the power of 0? It's because it's a horizontal line. So I'm going to go more in depth about horizontal line. Can you see this horizontal line? Where does it cut? The x-axis or the y-axis? It cuts the y-axis. So wherever it cuts the y-axis, let's say for example, this is 2. So it means that the equation is y is equal to 2 x to the power of 0. And anything x to the power of 0 is 1. So this is just y is equal to 2. Okay, for this kind of line. So there's one more line that is called, this is called the horizontal line, since we are already at here. So I'm going to go through the horizontal line. The next one is called the vertical line. So what is the vertical line? So the vertical line means it cuts where? The x-axis or the y-axis? X-axis. So it cuts x-axis. Let's say here this is a negative region. I call it as -1. So what is this equation of this line? Will be called as? Yes, x is equal to -1. But why is this vertical line not in this picture? Because if you notice in this picture, everybody is all y. Y as the subject. Understand? That's why I didn't include the one in brown. Because the one in brown is x as a subject. It's a different story than the one in the picture. So far, so good? So the one in red, orange, and green, you all get it already, yeah? So now I'm going to move on to the next 3 diagram. So this one, I call this as the one in yellow. The one in yellow is called the diagonal line. Because remember lines, we got 3 kinds of lines. We got a horizontal line, vertical line, and a diagonal line. Now, for this diagonal line, it's always in the form of y is equal to x. Y is equal to x. And x is to the power of 1. Okay? Diagonal line, y is equal to x, whereby x is a power of 1. Okay? So the next one is a U shape. So change highlighter color. This U shape is represented by y is equal to x squared. Now, do not be confused between y is equal to x squared and y is equal to x to the power of minus 2. How come? Because can you see this is a power of negative 2? So power of negative 2, right, guys? Look here. Y equal to x squared means when you want to draw your graph, it will look like that. Got it? This is y is equal to x squared. But y is equal to negative 2, it will look like this. This is y is equal to x to the power of negative 2. Understand the difference now? So once you understand the shape, everything will be a lot easier. Okay, now I'm going to move on to the last one, which is like the wavy hands. So I'm going to put this as purple, wavy hands. So wavy hands means this is y is equal to x to the power of 3. Y is equal to x to the power of 3. So if you look at the one in red, orange, green, blue, yellow, and purple, they all have something in common. What do they have in common? It's always y as a subject is equal to x as a base. And then they have a power, and this power is a constant term. So have you all written everything down on your plain piece of paper? Now, once you have written everything down, I'm going to teach you another concept. Okay, what is another concept? Another concept is where, can you see the base is not an unknown? Meaning, I'm going to flip it the other way around. What is flipping it the other way around means? Means right now I have y as a subject still, but my base is a constant term. My base is a constant term, and my power is x, which is an unknown. My power is an unknown term. Okay, so how will it look like? If you look at your notes, it will look like this. It's called an exponential graph. So you can imagine it as, you know, like a plane, it flies off. So this is the runway of the plane, and then it rises and fly off. So you imagine it as a plane flying off, taking off from the runway. Got it so far? Okay, so you understand all the parent graph already. Now I'm going to teach you the next step is the modification of it. Now, before I move on to the modification, you need to know what I call asymptote. Can you see here? This looks like it's almost parallel in this area here. So what is the asymptote? This is the asymptote, meaning this end of the graph can never touch this line. And this asymptote is called y is equal to 0 asymptote. You all write that down? So what other graph also have asymptote? Which one do y'all think it is? There's a red, orange, green, yellow, blue, and purple. Which one do you think have the asymptote? Yellow? Nope. Yellow is a diagonal line. Diagonal line has no asymptote. Whose has asymptote? Purple? Purple also have no asymptote. The purple has no asymptote. Yes, the red one. So the red one is, now we are on asymptote, the concept on asymptote. The red one means it looks something like that, right? This is your graph, correct or not? How many asymptote do you think this red one have?
2.
Yes, it has 2 asymptote. Can you see that this is one of the asymptote right here? So what is this asymptote called? Okay, let's continue. So over here, what is this called again? What asymptote is this called? Yes, so you said that there are 2, right? Where's the next one?
The y-axis.
And what is this asymptote called?
X equals 0.
So can you see how I draw? I draw like literally very, very near the asymptote. There's no, axis. There's no gap at all. And this is called the x equal to 0 asymptote. Now, there is one more graph with asymptote also. Which one do you think it is? And this is called the y is equal to x upon minus 2. There's one more graph with asymptote. Who is it? The orange. Very good. And the orange means it will be here and here. Agree? And what's the name of the orange graph? It's called? X to the power minus 1. So where are the asymptotes? The asymptotes will be also the same. Here, the one in red and the one in red, the same thing. X equal to 0 and y is equal to 0. These are the 2 asymptotes. Okay, dokes. Okay, so we have already learned the basic of the name of the parent graph. That's number 1. Next, we have learned is the asymptotes, right? Now we're going to learn is the modification. So let's start with something very simple. That is the one in blue that you have been familiar with since Set 2. All right, so the next one I want you all to do is to write the modification. Now, what are modifications and what are the variations that you can have? So you're write down already? The heading called modifications. Okay, don't draw the box yet. You can do it later because you might not know how much spacing do you need. So I will start with the basic one that we are all very familiar with. It's the parent graph. Remember just now we learned parent graph? So this is a parent graph. It's a U shape whereby it cuts 0, 0. When they say y is equal to x squared, and this is something you need to memorize. So can you see the power is a 2? So if power is a 2, means you know it's a happy face. Why? Because it's positive, right? So there are a few modifications you can have. The first modification you can have is, I'll erase this, and write here. What do I mean by a few modifications? It's number 1. Can you see here is a negative? The coefficient is a negative. The moment you have a coefficient is negative, it means that it's a reflection on x-axis. So can you see the parent graph? It's the same. Just that now I reflect. Can you see the reflect? And that's what it meant. Clear so far? So if they say y is equal to negative x squared, you know that this is what they meant. Next, same thing still. I have y is equal to x squared. Here. Okay, I'll give you all some time to copy first. Okay, so what are the difference? So for example, I'm going to do this one. It's, for example, 2x squared. Okay, the parent graph is 1, correct or not? If they don't write anything, it's always y is equal to 1x squared, right? So you can see from 1 to 2, the number become bigger or smaller? Bigger. So when the number is bigger, do you think it will be more steep or less steep?
More steep.
So bigger means more steep. Now, when it's more steep, do you think the curve will be skinnier or fatter? Skinnier or fatter? When it's more steep. Think about gradient. When it's more steep, it will be skinnier or fatter?
Skinnier.
So it will be skinnier. Like that. Slimmer. But the shape is still there. I never do a reflection or whatnot. My shape is still a U shape. But just that right now it's a skinnier U shape. So let's say I can even have, like, for example, y equal to x squared, right? But maybe I can have like a fraction. So a fraction means, like, for example, half x squared. So remember, this is your parent graph. Always compare with the parent graph. So the parent graph is the one in black, right? But right now it's half. So is the number bigger or smaller now?
Smaller.
So smaller means, do you think it'll be more steep or less steep?
Less.
Less steep means skinnier or fatter? Fatter. So fatter means here. But it's still a U shape. Just that right now it's opening up more. It's more fat. Okay, so we have already learned 2 variations. Now, what other modifications you can have? Same thing. Y is equal to x squared. But right now, I don't change the in front stuff, meaning the coefficient of the x squared. Now I change the back of it. So this is the parent graph. Because the parent graph, when they don't add anything, by default is always what? Behind. By default, it's always what? Plus 0, right? That's why, can you see here is 0? So what happens right now, right, is that I'm going to change this person right here. Meaning to say I have y is equal to x squared, same thing. But right now it's plus 2. So when you see the behind, plus 2, what does that mean? It means that the whole graph, what happens to the whole graph?
The intercept will change.
The whole graph, what happens? How will it move?
Move up.
Move up by how much?
2.
Move up by 2. That means that right now, instead of 0, I'll cut at 2. So it'll be like that. 2. And this is y is equal to x squared plus 2. Now, same thing. I have the parent graph, y is equal to x squared. But instead of plus 2, right now, I will minus 4, for example. So minus 4 means, where does it cut the axis? -4. So right now, this is how I draw my graph. Whereby this, it's -4. And what does this mean? This means that my whole graph, what happens? What happens to my whole graph? It will. What happens to my whole graph right now? Move what?
Move down by 4.
Yes, move down. Now the keyword is down by 4 from the parent graph, which is the black one. Now, these are all the modifications for just now that parent graph that I showed you, correct? So you can apply it even for y is equal to x cubed. You can apply it for y is equal to negative, to the power of -2. Just that be very careful, okay? Especially, remember just now I told you the two graphs that has asymptote. What are the two graphs? Give me one of them. What is one of them, the name? X to the power of? And how does x to the power of -1 look like? It is which one on the face? The what? Smiley face.
It's the X on the face.
The what?
The X on the
It's the bruised. Not the smiley face. The smiley face is x to the power of 2. Can you show me which one? Are you looking at the right place? Can you point it to me? Where? Show me. I cannot see. Where? Can you bring nearer? Where is it? Yes, it's the bruised. So when you draw the bruise, you need to be very careful. Can you see, guys, here is parallel. Here is parallel, right? Guys, can you see? Parallel, parallel. Curve. Parallel, parallel. Curve. Right? So this is the asymptote right here. And right here. So for example, if let's say the question right now says that, hey, I want a +2. What does that mean? You need to be very careful. +2 means everything moves up by 2, including the asymptote. So right now, my asymptote, the red one still stays. But will this one still be x equal to 0? I mean y equal to 0? It will not be y equal to 0. In fact, it will be exactly. It will be y is equal to 2. This will be your new asymptote. But this one has no change. And how do you draw now? It'll still be the same. The shape still stays the same. Right now, it's just moving everything up by 2. And you need to be very careful. When you move up by 2, you need to go and find out what is this x-intercept. Right? Because now you will have an x-intercept. And how do you find the x-intercept? What do you do? When you have an x-intercept, what will you do? You will... How to find x-intercept? Yes. You sub y equal to 0. And vice versa, if you want to find the y-intercept, means what must you do? To find the y-intercept. If you want to find the y-intercept, what do you have to do? Very good. Sub x equal to 0. Okay, so what is exponential? Just now we all learned was y is equal to, the unknown is the base, right? And the power is a constant, correct? But right now we're doing the reverse, whereby our base is the unknown. No, our base is a constant term, and the power is an unknown. So you can see here, the power is an unknown. Okay? So now, whenever it comes to exponential term, it must always be in this particular format. So what is this particular format? It's called y is equal to something times something to the power of x. So what is something times something to the power of x? Usually I'll call this as A and I call this as B. Now what is this A and B? This A is referring to whenever there's a position of A, this A is the y-intercept. Y-intercept means the part where it cuts the y-axis. And what is this B? Now this B has two scenarios. Scenario number one is whereby your B, okay, is between 0 to 1. And this B determines the shape. So you all can write that down. It determines the shape. Now, what is scenario number two? Scenario number two is where B is greater than 1. And B is greater than 1 is also another shape. So now, here is the range, right? It means that the value of this B, when it's 0 to 1, is a decay graph. So what is a decay graph? A decay graph means it's like an airplane landing down. It's an airplane landing down. Okay, like landing. And when it's greater than 1, it's like a growth. Right? So growth means the airplane takes off and fly up. And that's the two different shapes that you need to know. And where's the asymptote? It always have an asymptote. This is where the asymptote is for the default parent graph. The one in red is the asymptote. Y equal to 0 is the asymptote. So you can take your red pen and put dotted line and write that down, y equal to 0. Now, there are 4 different scenarios that you can learn. What are the 4 different scenarios? The first scenario is whereby I have y is equal to 2x. Can you see it's not in the form of a times bx? So this is when your indices must be really good. So what do you think the A is for this case? So you say your A is 2. Any other response? Yes, it's 1. Because the 2 you cannot separate out. 2 goes with the x. So it's 1 times 2 to the power x. So that means that I know my asymptote is, not my asymptote, my y-intercept is?
What happens if you put it in reverse? So that means y equals to 2 times 1 to the power of x.
No such thing. It's wrong. 1 to the power x is not the same as 2 to the power x. One to the power 7 is it the same as 2 to the power 7? It's not the same. So for this case, I know that my 1 is the yes, y-intercept. Next up, can you see this 2? So this 2 is the B value, right? So is this a decay or growth graph? So is the airplane landing down or airplane taking off? Airplane landing down or airplane taking off? So it's an airplane taking off. This is your y is equal to 2 to the power x, whereby your x-intercept, this line here is how much? It's not 2. Yes, it's 1. This is your y-intercept. So this is variation number 1, the simplest one. Next up, variation number 2 is whereby they say y is equal to 3 bracket 5 to the power of x. So does it look like in the form of something times something to the power of x? Yes or no? No, right? It's not. Because I need to rewrite it properly. So how do I rewrite it as?
3 times 5 to the power of x.
So whereby I know that right now, my 3 is referring to the And what about this 5? Growth. So I know the shape is a growth graph. So you can see I color code in orange and blue, and I hope that you also do the same. So this is a growth graph. Y is equal to 3 bracket 5x, and whereby this person here is how much? 3. The end. And do not forget that for both scenario, you need your asymptote. Y equal to 0, asymptote. Now, number 3 and number 4, actually, there are 5 different variations. So let's move on to number 3, variation number 3. Now, variation number 3 is y is equal to negative 2 to the power of x. Now, this is the part that a lot of students get it wrong. What do I mean by they get it wrong? They'll write as, oh, this is y is negative 1 times 2 to the power of x. This is what they will get it wrong. It's actually not right. Okay? So how do we go about doing this? There is a bracket here. Okay? There is a bracket here. What does that mean? It means that I must do this first, the one in red. So how do I do the one in red? By now, you all should know already, right? The one in red, this one here, what does that mean? It means that my intercept is 1, agree? And it's a growth graph. So this is y is equal to 2 to the power of x, right now. Now, can you see here? In front, there's a negative. Do you all remember what I teach you all about the negative in front? Who remembers what we learned just now? When there's a negative in front here. Sorry? Reflection where? Reflection where? Reflection on the, just look at the notes. Reflection on the x-axis. So what does that mean? It means that, guys, look here, we reflect down. So the one in red is not the answer. So at the end of the day, what is my answer? This is my answer. Reflect down. This is my y is equal to negative 2 to the power x. Got it? Whereby, how much is this person here? This green dot. How much is this green dot here? Yes, negative 1. Okay? So far, so good? So this is variation 1, 2, and 3. I have 2 more to go. Can I clear screen? Can? Copy everything already? All right. So what is the next one? Next one is variation number 4 and variation number 5, and then we are done. So variation number 4 is y is equal to negative 3, 5 to the power x. Now, how do we go about doing this? It's the same thing as just now. Remember I told you, put a square bracket here. And this is the one we need to do first, correct? So how do we do this? By now, you all should know that this is 3 is the intercept. And it's a growth graph. Agree so far? Anybody lost? Now, can you see here? There's a negative in front. What is this negative? What does it mean for this negative? Reflection where? On x-axis. So it means that this is the reflection, right? So ultimately, at the end of the day, what's my answer? This will be my answer. Y is equal to negative 3 bracket 5 to the power of x. Whereby, how much is this blue dot here? Done. Now the last one, the best for the last. Number 5. Y is equal to 2 to the power of negative x. And very high chance, number 5 is the one that you see in the exam. Now, let's do a recap. What's the recap that we learned so far? What must the format be? Do you still remember?
A times B.
Must start with who first?
Y.
Y is equal to?
A times B to the power of x.
What do you notice with the format that I know of and the format right here?
Positive x.
Very good. The format here is positive x. But what's the problem with this one?
It's negative.
Negative. So do you all remember you all learned in indices? Right? There's a way to make from negative to positive because you know for sure your x must be positive. So not many students know this.
1 over 2x.
What do you want over 2x?
1 over 2.
Like that, 1 over 2x. Is it right or wrong?
Wrong.
This is wrong. Huh? So we need to rewrite this equation into y is equal to 1 over,
1 over 2 to the power of x.
but we have a problem. What's the other problem? Can you see it's still not something times b to the power x?
Yeah.
So how do we rewrite this? It's still not in the form of something to the power x.
1 over 1 to the power of negative
1 over 1 to the power of negative 1.
No, I mean the y, you change the, you flip it the time.
There's no way you can flip the y. The y must stay as y. The left-hand side must always be y. Y must always be the subject. You know that die, you definitely need something to the power of x. So how am I going to rewrite this using indices? So usually students will be very used to write in this form, but I won't. Instead, a better way is to write two to the power of x bracket negative 1. But you still cannot get into this format. Something to a power of x. So you can just flip these two around. 2 to the power of negative 1 to the power of x, right? And what is 2 to the power of negative 1? What's 2 to the power of negative 1? Which is? Half. Done. Then didn't I get what I want already, which is b to the power of x form? Correct? But it's still not in the form of something times something. So how do I write this again? I can still rewrite this.
1 times half x. 1 times half to the power of x.
You need to be very careful. You need something. You're missing on something. 1 times what? Yes, bracket. Half followed by? Yes. So I'm going to erase all this so that all this will not be a distraction. So right now, I get it in a proper format already, right? So I know that what is the 1 referring to?
The y-intercept.
And how much is the y-intercept?
1.
1. Next. What is this half referring to?
Decay shape graph.
Decay graph. So decay graph means what? Airplane flying off or airplane landing?
Landing.
Airplane landing. Whereby where's my asymptote? Still the same. Here. And question number 5 is the kind of question that usually will be out in tests or exams. So, and that's a crash course for power graphs. The end.